So we have seen functions as well as the details of debugging some functions. We have seen F11, Shift F11 and stuff like that to go into and out of the function. So one of the very important thing I would like to mention here is that the debugging is super important. Beginners misunderstand or overlook the importance of debugging. So the session we had just so far about debugging is very important. So you need to understand where to put a breakpoint or how to put a breakpoint, the use of a breakpoint, F10, which is the single step, and F11 and Shift F11. And looking at the variables, watch, locals, all that sorts of stuff. Also, as I mentioned, function is a very important concept. It is there in all programming languages, including assembly language. In fact, very few concepts which I'm discussing in this training is there in assembly language. Assembly language is the lowest possible programming language we have. Python generate assembly language programs internally. We have seen that in the previous chapter, the machine code. The function is one of the very few functionalities which is there in the assembly language as well. Functions translate to call instruction. I'm not going to the details of it, but it is very important to understand the use of functions. Normally, there is no much of a trouble with functions. They are easy to understand. So coming back to the slides, so we have seen F9, which is the breakpoint. We have seen this as a review. I'm mentioning it again. F5 is continue, F10 step over and step into a function which is F11. We have seen this as well. Shift F11 is complete the execution of the function and come out of the function. So that is step out. So these are the important artifacts when it comes to debugging. So we will be using this a lot in the rest of the training. Also, we have seen locals. When we discuss scope, I'll explain what exactly locals are. Also, we have seen watch, where we look at the value of a variable, watch window. Call stack is something optional. I have shown you when you get into real programming, production level programming, call stack is probably the most useful out of everything. I'm not going to the details of it. For the time being, we need F9, F5, F10, F11, Shift F11, locals, and watch. Those are the things we will be using for this training. Next concept I would like to introduce is the concept of import or libraries. Libraries are nothing but a group of function, normally which is written by someone else. So we have seen the print function, we have seen the input. We were calling those functions, we were using those functions. We didn't see the implementation or the definition of that particular function, input or print. So where is the implementation of those functions? So it is implemented by someone else in some library. And that's what we're gonna see next. So again, we will see some samples. We'll get a feel of the code before we get into the theory. So let's get into some examples first before we get into the slide. If you want, you can pause the video and read through the slides, but we will take each and every point later after going through the example. So this is the code we have here. I'm going to comment this line out, line number 3. So it's a very simple program which has only 2 lines. Now, what we are going to focus is this one particular statement, line number 1, import, which is a keyword. We discussed keywords are special words inside the programming language. Import is one of them. Import is a keyword. So import OS. This line means that introduce this particular library into this program, and we will be able to use the functions along with other things. There are other things in this library which we will see shortly or in the future lectures. But for the time being, what we are doing here is we are introducing the functions which is defined inside OS into this program. That's what we are doing here. And in line number 2, we are using one of those functions called system. System is a function like the one we saw, and we are passing an argument right here. So what this function does is it goes to the operating system. So OS is operating system. In this case, it is a Windows where I'm running this presentation. It'll go into the console of the operating system and execute this command. That's what it does. It goes into the console or shell of the operating system, this current operating system where I'm running, and execute this particular command. So we are expecting very similar to print, but in a different way altogether. The difference you will understand when I execute this. But for the time being, let's get a feel of it. So I'm going to put a breakpoint here and start debugging. So right now I have this import done. And this whole thing is imported. So let's have a look what is being imported. So a lot of things have come up into the program. So this is all coming from the library OS. So this particular module, library, a lot of different names we use for this particular thingy right here. Basically, it is a group of function or a chunk of code written by someone else, which we are using here. Now I'm calling this function, I'm going to press F10, and as you can see, there is a print here. Now, if I copy and paste this particular line here, I'm copying this and I'm going to a command prompt. From the run, I have started a command prompt and I'm pasting it here. I get the exact same result. Basically, this is what Python did, more or less. It started a shell and executed this command inside the shell. That is just the tip of the iceberg. OS can do. OS can do a ton of things. For example, if I do OS dot, I get ton of things right here. There is system here, so many other things you can see. And this feature of Visual Studio Code, where you can see what are the options available inside a library or a module, is called IntelliSense. IntelliSense or autocomplete. If I click on here, it will come like so. And I can call that function whatever it is. I don't know what this function does. Doesn't matter. You can check the documentation. So this is available in documentation. So whatever OS can do, it is there in the documentation of the OS module in Python. Right now, what we have done, we have just used a function called system and started the shell and executed this particular command in the shell. Now what I'm going to do is I'm going to comment this out and uncomment this line. So this is more interesting from the execution perspective. Otherwise, this was looking just like a print, no difference. You can print that just like we do in Python, but this is gonna do slightly different stuff. Let's see what's going to run. Again, I'm start debugging. I have a breakpoint which was on a line which was commented out. So the breakpoint automatically moved to line number 1. This always happens. Not very important, just mentioning. Again, step over. I'm going to execute this particular line, explorer https://facebook.com. That's familiar. So let's see what that does. I'm going to execute that particular line. Let's see what happens. As you can see, it opened up a browser and gone to facebook.com like so. So very powerful function. You can execute pretty much anything in this operating system. So there was an example in which the operating system shutting down after executing this because there is a shutdown command executing here. But the problem we do that is because it will kill my recording and you will not be able to see anything once we execute it. It will shut down my entire system. But in the live session of this training, I used to do that. But right now it will kill my OBS and you will not be able to see anything. So shutting down you can do. The command is shut down if you want to try it out yourself. So any command you can do, ping, shutdown. There are tons of commands available in Windows as well as Linux based on the operating system. If you are in Mac as well, this will work. Now, a few things I would like to tell you here is one is this particular module or library has a lot of functions inside. We have seen that. So if I do os dot, we will get a ton of things here. So what if I don't want all of these things? It may be polluting my program by importing whole thing. So what I can do is I can add another keyword called from OS import system. So I'm just importing system from this module. Now I need to fix this as well because I'm not including the entire thing. So all I need is this. This is a better way to do it. In this case, we are specifically telling the program just import system from OS. I'm not using anything else other than system. OS has a ton of things which I don't want. I want only system. That is where the from comes into the picture. From OS import system. So this has the same effect as the previous program. It'll just run and execute this particular command. I'm removing the breakpoint and this time I'm going with continue. I don't want any execution. So it opened up another tab in the browser. So another point worth mentioning is, why do we need import? Why can't we by default import everything into the program so that, we can avoid this particular line altogether. We can avoid that particular line altogether. And line number 3 will work just like the print function we were using before. Why can't we include everything by default? The answer to that question is because that'll keep a lot of load into the Python compiler. It'll have to look into a lot of things if you include everything in the beginning. So by default, only minimal stuffs are available and other things as needed we include. Python has a lot of things like data science, artificial intelligence, automation, system programming, a lot of things you can do with Python. But some people may need something, some people may not need something. That's why import is there. Import is not a concept which is specific to Python. It is just like everything else in this training. It is applicable to all programming languages. C, C++, Java, C#, Golang, you name it. This concept is there in one way or the other, including libraries, which are nothing but a group of function into the program. It's a very common thing. So I'm uncommenting this. So we get the program working. Now what I wanted to show you is that the documentation of a package or a module. So if I search for OS package Python, so this is the official documentation of that package which we used, package or module or library, all same stuff. There are different names which we use for all these things. Control F, system. I'm just trying to find out the documentation of that function we were using. So I got a reference of os.system right here. I'm clicking. As you can see, the complete documentation is here. You may not understand much here at this point. Don't worry about it. So you will get there. So these are for relatively on the expert side to understand, read and understand. In actual programming, mostly you look at the samples rather than reading the documentation. Normally you copy paste samples. So we'll try to understand how to do all those things later. But what I'm saying right now is every package normally is documented. Every module which we include is documented publicly. So there are a lot of libraries like this we can use in Python. That is one of the strengths of Python language. Python has one of the strongest widely available library set. Practically anything you can do with that. Now getting back to the slides. So we have discussed the concept of import. It is nothing but adding the support of a group of functions into our program and use those functions. So the group of function is called library. So there are so many different names out there. Library, module, package. Depends on the programming language. It is called package strictly in Java. I have not seen anything else, but it all means the same thing. It's a group of a function written by someone else. And by including that in our program, importing that into a program like we did, we are making it accessible or usable from our program. Remember when we commented that OS import OS line, we got an error in our system line. So the program said that, hey, I don't know system anymore because you have not included any package to tell me what it is. So making it accessible to the program, very important point. And more than often it is written by someone else. Mostly, this is the key here, mostly. It doesn't mean that it is always written by someone else. In the advanced section of this particular training, you will see how to create a package, how to create your own package and include that in your program. So that is also coming up. But more than often, it is written by someone else. But you can create your own packages as well, give it to someone, and they can use it. Some of them are within the language. Some of the libraries are part of the programming language itself. They have a different name called standard library. Standard lib. Standard lib is nothing but packages or libraries or modules that comes with the programming language itself. You don't have to do any special installation. Print was one of the part of the standard library. OS was part of the standard library of Python, but we will see some of the packages which are not part of the standard as well. For that, you need to do a pip install and some installation. Basically, some files you need to introduce into the system to use those libraries. They are not part of the standard installation, standard package. Yeah, some libraries you need to install separately other than the Python installation we did. But after that, you can use it the same way we are using the standard library. Standard library is part of the language like the ones we have seen. This is the ultimate free lunch in the world of programming, which means that you are using some free code which is written by someone else. If you start writing a program to launch a browser and go to Facebook, it'll take a lot of time in Python. You were using the code used by so many people to see that part of the execution. This is a very useful feature by which you use the code written by someone else. So import, include, library, module, package, all these things are pretty similar. Include a library, include a module, anything and everything is pointing to the same stuff. So we have seen the example of input. We have seen this example. We have not seen this because of obvious reasons which I discussed. We have seen from as well to restrict the amount of things which is getting imported to your program. It is kind of a way to avoid pollution. So there will be so many things coming into your program when you execute this statement. Everything inside this thing will come into your program if you simply write this. To restrict that, to clean your program, we got very specifically the from statement. It's a keyword again to execute or only import this two things. And we have seen to import just this one particular thing. So that is the use of from to restrict the amount of import from this library or module. Also, we have seen so many functions we had in the OS package. We didn't import all of them when we used the from statement. Only system we did. So very important. This is the best practice to import something. Then there is something called as keyword. We will see that later. Again, kind of a similar purpose, but on a different way. It is the as keyword, as, which we are not discussing now.